Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again. This is the podcast they call Space Nuts, and it usually comes in packets of 2. Andrew Dunkley, that's me, and from the Australian Astronomical Observatory, Fred Watson. Hello, Fred.
Hi, Andrew. I'm always happy to join you in a packet of 2.
Yes, very good. I'm just trying to figure out what kind of nuts we are. You have the brain, so you're a walnut. And I don't know.
I don't think you should analyse that too deep.
What's small and meaningless in the nut family? We won't go there. Now, today we're going to be talking about an asteroid, which is the subject of a mission that NASA's putting together. And this asteroid, as I understand it, is a little bit different from others, and we'll get you to explain why. And we're looking at astronomical sign, not signs, sign. This is a new language, or a new part of a language, where the International Astronomical Union has created a sign language to help the hard of hearing to learn more about astronomy, I gather. We'll find out about that. And Bradley. No, Bradley's not an astronomical body and not a spaceship or a planet. Bradley's a person who's asked us a couple of questions. So we'll get to those for you, Bradley. We don't know where you're from, but we're sure you know who you are because there just really aren't that many Bradleys around. But first, Fred, let's look at this Psyche mission of NASA's to take a look at what is seemingly an unusual asteroid.
It is a very unusual asteroid, and it's one which I hold in some affection, Andrew, because when I was embarking on my master's deep degree work, my topic was understanding asteroid orbits. And so I had to observe some asteroids and work out their orbits and calculate all that stuff. And it almost drove me mad, but it nevertheless was interesting stuff. And the first asteroid that I tried out all my new sparkling software that I'd written on was Psyche. This one that we're talking about tonight. Today. Or this morning, or this evening, depending on when you're listening.
Exactly.
It's Psyche, Psyche, slightly psychological, I guess you could call it. It was the 16th asteroid to be discovered, so it's usually known as 16 Psyche, and 16 Psyche plays its part in my master's thesis at the University of St Andrews. But it's now known, which it certainly wasn't back then, this is hundreds of years ago, we now know that Psyche is probably unique among the asteroid belt, because whereas most asteroids are pretty stony objects, they're rather rocky, this one is made almost entirely of metal. It's a nickel-iron asteroid. So its composition, could hardly be more different from your average asteroid. And that makes it of interest to science because we think that Psyche was probably once the core of a planet that was being assembled within the solar system. So the way planets form is you start off with a cloud of gas and dust, and that collapses under its own gravity. And at the middle, you get a huge ball of hot gas, which is like the sun. That's the star. But the dust and the gas, the remnant gas, swirls into a disk around it. We call it a protoplanetary disk. And within that disk, you start to get planets forming. And the bottom line is that bits of dusty material stick together, and eventually gravity pulls more and more of them together till you've got something the size of a football field, and then they stick together, and you get something the size of the moon. You build what are called planetesimals. These are sort of baby planets, and then you get to a stage where the thing is big enough for its own gravity to pull it into a spherical shape. And in doing that, it heats the planet. It's probably hot anyway from the collisions of material. But all the heavier elements sink to the middle. And so you get the rocky stuff forms the mantle on the outside. You can probably hear banging, by the way, which is the horse next door. The usual.
That's right, because you live next door to a veterinarian.
Yeah, pretty metallic stuff going on there. The heavy elements sink to the middle. It's a process called differentiation, and so what it means is that you form these objects which have got a metallic core and then a rocky mantle over the top of it. And that's basically the structure of the Earth. And we think the other planets, certainly the other rocky planets. Mm-hmm. So at the middle of planets, typically, you're going to find a metallic core. But in the early history of the solar system, planets were not in their well-behaved, circular orbits that we have now. They were charging into one another in a fairly random fashion.
Yeah, it was a fairly cataclysmic time in the history of the universe.
That's right, there was. In fact, about within the first 600 or 700 million years of the formation of the solar system, that sounds like a long time, but the solar system's a lot older than that. It's about 4.6 billion years old. But within those first few 100 million years, there was an episode called the Late Heavy Bombardment, and that was a time when lots of things were charging around in the solar system, and planets not only were being built, but they were also being demolished. The process is a kind of cyclic one, and so somewhere along the line, a big object hit this protoplanet, this thing that was going to turn into a planet, and knocked it to pieces. And one of the remnants of that is Psyche, because the Psyche is the remnant of the core of this object that never made it to planethood. And that makes it very interesting to planetary scientists. So the plan is to send this spacecraft, which will investigate the surface of Psyche. We've no idea what a metallic asteroid surface will be like. It might be quite shiny and polished. It might be overlain with dust. It might have all kinds of bells and whistles on the surface, rather than just the craters and mountains that we expect to find on a rocky asteroid. So the spacecraft will be equipped with magnetometers and multispectral imagers and gamma ray spectrometers, neutron spectrometers, the whole remit of stuff that we take into space to investigate these other worlds, as well, of course, as cameras and things of that sort. The reason why we're talking about this today is that the mission has actually had a bit of a boost, because the original plan was that this mission would not be launched until 2023 and was going to take, I think, something like 6 years to get to Psyche. But the mission scientists have been instructed by NASA to look at bringing it earlier. And in fact, they've got a new plan, which involves a gravity assist from the planet Mars. That's when you fly by a planet and get a kick from it to boost your speed. It involves now a launch in 2022, the northern summer of 2022, and a planned arrival at Psyche, whose orbit is between the orbits of Mars and Jupiter. It's what we call a main belt asteroid. Mid-2026, so 9 years' time, we will expect to see that. Actually, it's 4 years earlier than was planned. It was originally planned to get there in 2030. So for Psyche enthusiasts like me, that's really great news, because, I might last that long. You and I might still be talking about this stuff.
I should hope so, Fred.
Yes, I do too.
The thing is, I would imagine that they would have already laid down their plans, done their calculations, worked out what they needed to work out, fuel loads, trajectories, escape velocity, or whatever else, for the original plan. And now they've had to work it all out again. Surely that'd be a mixture of joy and frustration.
Probably, that's right. I think a number of things, though, have made people fairly joyous about this, because one of the things about the new trajectory that the spacecraft will be on is that it doesn't go quite as close to the sun as was originally planned. It was going to pass, I don't know how many million kilometers away, but close to the sun and close enough to give the mission scientists a bit of discomfort. So basically, you need less heat protection now for the spacecraft. It doesn't need to have all the reflective armoring that you would have needed before.
And they'll save on 30 plus sunscreen, so that's good too.
That's right, yeah. Actually, they use 50 plus sunscreen.
Do they?
For this. Yeah, no, 30 plus.
I'm told it doesn't make much difference.
No, that's right. It certainly doesn't if you plaster it on a spacecraft that you then watch through the atmosphere.
And I gather that the window of opportunity to connect with Psyche is pretty wide, because you don't often have these big variations in time when it comes to intercepting objects like this.
It really depends on the relative positions between Psyche and the Earth when they're when their orbital parameters all align. Of course, that's one of the issues about human spaceflight to Mars, because there are only certain times when you can make the transfer between the Earth and Mars. And then when you get there, you've got to wait a year and a half or something before you can get back because of the alignment that you need. So you're quite right. This is a one-way trip. The spacecraft will wind up in orbit around Psyche, and will basically, spend the rest of its days there. There's no problem about bringing it back. It's certainly not going to bring back any sample return from Psyche. All that we will learn about that weird asteroid will come from the equipment on board and the images and things of that sort. But I think it's pretty exciting stuff.
It is, and we may well then learn a bit more about what goes on inside our own planet. We haven't seen our core. We haven't
exactly. That's the whole nub of the issue. That the metallic cores of planets are really, you've got to work pretty hard to get any information about them at all. In fact, most of what we know about the core of the Earth comes from seismic observations, where you get earthquakes and you watch the way the seismic waves are refracted and reflected within the Earth. That's what tells you what the Earth's structure's like, plus a bit of modelling to try and understand what a planet would look like, a hypothetical planet, if you put it together. But to have the opportunity to investigate something firsthand is really remarkable and worth doing.
And until they develop 1 billion plus sunscreen, we won't be able to go down there. So we might as well just go to somewhere else in the solar system and look at something that's already been made earlier. Very good. All right, you're listening to Space Nuts. We'll talk more about that story as it gets closer, I hope. And you're with Andrew Dunkley and, of course, Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, we're going to talk about languages. Everybody, I think you and I have discussed before that the international language in astronomy is actually English. But we're going to talk about a language now that isn't spoken so much as it is signed, a sign language specifically designed to help people understand what's going on in astronomy. Is that right? The International Astronomical Union's behind this?
That's correct. The governing body of world astronomy, the International Astronomical Union, which I think has a membership of something like 10,000. So that's more or less the number of professional astronomers in the world. Their headquarters are in Paris. It's a very august body. They do meet more than every August, though, but they're nevertheless, a very serious and actually quite influential body. So, for example, what they do is they're responsible for the naming of celestial objects and things of that sort. It's the IAU that determines what names are given. And actually, they've recently loosened up a bit by inviting suggestions from the public at large for names of asteroids and dwarf planets and indeed stars. So all that's part of their remit. But one of the things that I think is really a very, very useful thing for them to have done has just been announced. They had a press release out about this last week, and it's the first list, it's a kind of international list of astronomical words in sign languages. So sign languages for the hearing impaired. The IAU has recognized that there's a need for a kind of international sign language. And it actually comes about because of the early efforts of someone I know quite well, a French astronomer by the name of Dominique Proust, who's actually related to the original Proust, Marcel, in a distant way. But Dominique, he works at the observatory in Meudon, which is kind of a suburb of Paris. Many times we have visited his observatory on the tours that I sometimes lead up to Europe. It is a very, I think, a tribute to Dominique that he kicked off this in 2009, the International Year of Astronomy, by creating a sign language for astronomy, or signing, in France. So it's in the French language. What he did was put together what you might call a dictionary of astronomy for the French sign language. It was called Hands in the Stars, and in fact that's what they're calling the international one. So Dominique was instrumental in kicking this thing off. He had about 300 signs, and they include, planets, asteroids, galaxies, quasars, as well as some of the words that we use for describing the instruments that astronomers, it's the astronomers' stock in trade, things like telescopes, spectrographs, photometers, polarimeters, and all of this sort of thing. But then over the last year or so, there's been a translation of Dominique Proust's dictionary into English, and now that is being basically translated into other languages. So we've got a whole range of international languages with these now internationally recognized signing symbols for astronomy. I think it's fantastic.
It's amazing. And I imagine what he's developed will be integrated into existing languages. So it will expand existing languages so that it includes astronomy as an add-on, if you like, so that hearing impaired people are getting the benefits that we've just enjoyed because we can hear. That's really right. Quite that simple.
Exactly. The International Astronomical Union, on their announcement about this, they say sign language is now officially practiced in almost every country, but diverse heritages and different cultures independently develop specific signs to designate common objects or identical situations. And then Dominique himself makes a quote, which is: a universal sign language is gradually being developed mainly to designate objects and situations relating to contemporary technology or events. Nevertheless, there will always be differences between signs in each country that need to be noted, as countries have developed their own signs through time. So it's not a trivial task to, just invent signs for these various things that we see in space.
No, and I imagine one of the problems he may have faced was not confusing a sign that he created with one that already existed in a language that was already being used. That could have happened.
It means something quite different. That's right.
Yeah. So that would have been, and I imagine in sign language there would have already been words for things like planet and moon and sun and that kind of thing. But he's gone to the, I guess, the extremities, the more intricate parts of astronomy, the areas that probably just weren't even considered to be represented.
That's right. I'm sure that's right. It'll be technical. With 300 words, you can guess that some of those will be quite high level of technology.
Absolutely, yeah. And it's interesting. I didn't know until I read up on it myself many years ago that there were different languages of sign. So there's actually an American version of sign versus the Australian and English versions versus French versus German versus. There are international languages in sign, just like there are spoken languages of many variations, which is fascinating. And did you know, Fred, this is coming from my bucket of useless information, New Zealand was the first country to officially recognise sign as one of its national languages. I
did not know that. And
they have 3 official languages in New Zealand: English, Maori and sign.
There you go. Yeah, I take my hat off to the Kiwis. They're pretty ahead of us in lots of ways.
Yeah. They were first to introduce the female vote too.
Yeah, great stuff.
Although I said something nice about them being Australian, I then have to counterpunch and say you and I right now are speaking on the anniversary of the discovery in New Zealand by a Dutchman who just went straight past. And they only named it after a Dutch province. It wasn't even good enough to be named after a human. It was just named after dirt. I've said enough. And just for the record, Fred and I did that whole segment in sign.
We did, yes, absolutely.
And I'm getting a few signs from New Zealanders right now too, Fred. Interestingly enough. Anyway, it'll be interesting to see how that goes. But it's so good that they're catering for an area that obviously would have as much interest in astronomy as other people, and until now haven't been able to take advantage of that. So it's very good news.
Great stuff.
You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Finally, Fred, Bradley. Bradley is a human. All we know about Bradley is that his name is Bradley. And he listens to Space Nuts, which I guess makes him slightly lesser than the average human. But anyway, Bradley, we appreciate it. And thank you for your questions. He's got 2 questions for us. Fred, will go in order of Bradley. 1, I hear there's a radiation dome blocking us from going to Mars and the Moon. Is this true or not? Well, it is one or the other, Bradley. And thank you for asking the question. What's the story, Fred?
So Bradley's certainly on the right track there. I don't know that we'd call it a radiation dome, but once you get above the Earth's atmosphere and away from the Earth's magnetic field, then you're in a very, very hostile regime. And of course, that's where any interplanetary travellers would be on their way to Mars, and indeed they are if they're on their way to the Moon as well. You're in a regime where the sun is spewing out these subatomic particles at quite high energies. That's called the solar wind. If you had a solar flare, this solar wind turns into a gale, and you've got quite dangerous subatomic particle fluxes going through space. And that's one reason why the International Space Station has parts of it which are fairly well safeguarded from this. They're kind of hardened areas which would be able to withstand a solar flare rather better than the normal areas. Having said that, the International Space Station is reasonably well protected anyway by the Earth's magnetic field, because it's within the radiation belts of the Earth, within the magnetic envelope that surrounds the Earth. Once you get outside that, then things look a lot tougher. And so a trip to the Moon, and even more so a trip to Mars, is essentially subjecting you to basically a radiation environment that is quite a lot worse than what we've got here on Earth. It's not just the solar wind. There are things called cosmic rays, which come from highly energetic processes in our galaxy and beyond. And so all these subatomic particles are kind of whizzing through your body all the time. Now, for a 3-day journey to the moon, which is what it took the Apollo astronauts, it's tractable. It's a radiation level which is one that can be dealt with by the human body. It's not that great. It compares, I guess, with having a fair number of X-rays here on Earth, and of course, witness the fact that the returning Apollo astronauts, generally speaking, have lived pretty long lives. And Buzz Aldrin's in his 90s now, I think. Is actually clicked over that mark.
Yeah, and still a very, very active man. I actually did meet him once. He's an amazing character.
I think so too. I had the same pleasure once too. Just let me work it out. I think they were 30 at the time of the mission, so that makes him slightly less than. Slightly less than. I think I've got that wrong. I think I'm calculating that wrong. I think that might be when they joined NASA. Yeah. So
I think they were pushing closer to 40s. Yeah, something like that.
Right. Yeah, I shouldn't do these calculations live on Space Nuts, but
hey, I do it live on radio sometimes. It's really a poison chalice, that one.
So there is a radiation hazard for a 3-day journey to the moon and back. It's not that arduous, but if you're going to Mars, then you really have to start thinking about hardening the structure of the spacecraft to mitigate the effects of the radiation. So it's not something that blocks us from going to Mars and the moon, as Bradley suggests, but it is definitely something that needs consideration and needs pretty detailed consideration too, especially if, as I'm sure will happen, we end up, not you and me, Andrew, but we as a species end up spending large amounts of time on the moon, which I think is likely to happen down the track. So the second question of Bradley's, you might want to read that too.
I will. For the record, Buzz Aldrin was 39 when he went to the moon.
Okay, there you go.
So he weren't far off.
No.
Weren't far off at all. And just something I've thought of in you answering that first question. We've already sent probes and things to Mars, so it's not the trip he's talking about, it's the effect that he's asking about. So
yes,
that exposure to radiation. I watched a movie just the other day, a new sci-fi called Life, which is about the discovery of life on Mars, and there was actually one situation where they were talking about one of the astronauts on the International Space Station who'd just racked up 400 and something days, and they were saying he'd reached the limit of his exposure to radiation.
Yep.
So they're talking about this kind of stuff in science fiction, and it's actually real. And one thing to be certainly concerned about, and refer to earlier comment about billion plus sunscreen. They've got to invent that soon and solve all these problems.
Just a little postscript, a further postscript to that. Of course, on the moon or Mars, if you're planning to spend a lot of time there, then you can actually burrow underground. There are natural caves on both those worlds,
and that's something they've certainly been talking about in the last 6 months or so, because they've discovered huge lava tubes on the moon where you could easily protect yourself from radiation. So it is definitely something that is being looked at seriously. So to question 2 from Bradley, when NASA first sent humans to the moon back in the late 60s, funny that, why haven't we been back? Is there a reason?
A number of reasons, Bradley, and I guess the main one is that putting humans on the moon was a huge endeavor in the 1960s. In fact, in many ways, it was ahead of its time. And the technology that was used to do that was, certainly by comparison with what we have today, fairly crude. But it was still very expensive. The figure that I have in my head, I think, is about 33 or 35 billion US dollars at the time. And that, of course, that would translate into a much higher price by today's standards. But of course, the imperative to go to the moon was entirely political, because the Cold War was at its height. That's the kind of political jostling between the United States of America and its allies and the Soviet Union and its allies. And there was a really big impetus to show who could get to the moon first as being a technological achievement that would actually stamp you as the leading technological nation in the world. And that's what the US succeeded in doing. But the political imperative to do that was so great that the amount of money, as I said, was actually extraordinary by the standards of the time, $30-odd billion. There's another thing, though, about why we haven't been back there. And this is, I think, to do, well, there's two factors to it. One is that we now know that with robotic spacecraft like Lunar Reconnaissance Orbiter, like Curiosity on Mars, like Mars Express, like Venus Express, all these fantastic robotic spacecraft that you and I, Andrew, often talk about. That is such a great way of exploring the solar system and bringing back data that we would not be able to do without huge expenditure in putting humans into these environments. And that's the thing. These days, because we are so much more risk averse than we were back in the 1960s, there isn't the same political imperative, despite the I think, relatively tense political situation in our world today. It's still not like it was in the Cold War. Trust me, I was there. I remember what it was like.
I remember too. I was sort of in the last 30 years of it.
That's
childhood.
Right.
Yeah.
And it was a very sobering time to be a youngster, in fact. So that political imperative is not there. We're more risk averse. We know we can do so much more by robotics. That is why we haven't been back. But it's not to say that we won't go back again. And maybe in the relatively near future. There was a statement from President Trump just this week, which was all about urging NASA to bring forward their lunar exploration program for humans, and with a view to using it as a stepping stone to Mars.
And
so
of course, China is certainly pushing to get people on the moon, definitely, and the US looking at Mars. So
that's right.
There is on the table.
Yeah, there is an element once again of competition about this. My hope, and I think it's probably my guess too, is that eventually, particularly for Mars, we'll find major international collaborations taking that forward, like the one on the International Space Station, which is really quite an extraordinary feat of international collaboration in a time when you wouldn't necessarily think it would be happening.
And as was demonstrated in the science fiction movie The Martian. That was international cooperation as well. So they were trying to send a message even through that platform. But we will go back there. There's no doubt about it. And but as you say, Fred, it can be a pretty dicey proposition. They'll want to make sure they've got everything figured out and make it as safe as possible, because Mars especially is not a quick journey. It's a heck of a trip.
It's not a cakewalk when you get there, either.
No, it's a hostile planet.
Yeah.
As much as we love it, and we just keep going back there and trying to learn more and more and more. But it'll be exciting though when they finally do. I hope we're around to see that. But it's not too far off. Fred, thank you, Bradley, by the way, for your questions, and we do encourage questions, so please send them to us via our Facebook page or our Twitter page. We do love to hear from you, even if it's just a passing comment. Always welcome. Fred, thank you so much. Always enjoyable.
Good to talk to you again, as always, Andrew, and I think we'll be doing another one next week.
One more before Xmas. And then we might have a little break, but we'll figure that out as we get closer. But we'll catch you very, very soon. Fred, thank you.
Sounds great. Thanks.
That's Fred Watson from the Australian Astronomical Observatory, and you've been listening to the Space Nuts podcast. And we thank you for that. And don't forget to tell your friends and, keep in touch. We do really like that. Until next time, thank you for listening to Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast. Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.